Good morning, everyone. So today we're going to move on with lesson 35, and I'll also do 36, but I'm going to put that in a separate video. So there'll be two separate videos, one for lesson 35, and then there'll be one for lesson 36. So you'll be looking for both of those separately. All right, so let's go ahead and start with lesson 35. What this lesson is about is factoring with the greatest common factor, and then we're going to learn how to cancel using that skill as well. So if you recall on Thursday, we were trying to identify finding greatest common factors of terms that had variables in them. We're going to continue with that. So the difference here, though, is you're going to start seeing now where we have actual expressions where we might have factors being added to other factors and factors subtracted from other factors. So let's take a look at that, because that's a lot of words that might not mean a whole lot until you see it in action. So let's look at our first example here. We want to look at 3x plus 6, and we want to be able to factor the greatest common factor. So what does that mean? That means I want to take this expression and I want to turn it into two factors, okay? When I think about the greatest common factor, I'm thinking about something that I'm going to show you that looks like we're going to be using the opposite of distributing. So what do I mean by that? Well, let's take a look at this. I am going to look at both of my terms here, and I'm going to try to figure out what they share in common. What is the factor that they share? Now, what we learned the other day was kind of a long method of doing that, but we're going to use that anyway. So let's see here, so I have 3x, and the factors of 3x are 3 times x. 6 is my other term here, so let's factor that into prime factors. And now I can determine what they share that is in common. They both have a 3, and that's it. Okay, so I'm going to take that 3, and I'm going to factor it out. It's the greatest common factor of 3x and 6. There's my first factor. My second factor is going to be what's left goes back into these parentheses. So when I look at the term 3x, I have factored out the 3. What would I put back into my parentheses that if I distributed it would bring me back to 3x? Well, that would be over here, it's the x that's left, right? If I distributed 3 times x, I would end up back here with this 3x. Okay? Now, there's a plus sign here, so that's going to stay in our parentheses. Now, let's look at 6. What did I factor out? I factored out the 3 part of 6. Over here, it's highlighted. What was left was the 2. That's going to go back inside the parentheses, because think about it. When I distribute this 3 with the 2, what do I get? I get this 6. So look at this. See if I can erase that without erasing. There we go. Perfect. All right. So this 3x plus 6 factors into two factors. One of them is 3. The other is x plus 2. And if I went back and distributed this, I would have 3x plus 6. So I can check it and see that I have factored correctly. So we factor out the greatest common factor. In this case, it was 3. That's what 3x and 6 share as a common factor, and the rest goes back inside the parentheses. And that's how we factor the greatest common factor. So it's like the opposite of distributing. Let's look at this one over here. Now we could do this process like we just did right here, but I want to see if maybe we don't need to do that, because the goal would be that I would learn how to look at these problems and identify what the greatest common factor of each term is. So let's look at 4mn and 2mp and see if we can determine what the greatest common factors are. Remember, it's factors that they share. Okay, so the first thing I'm going to look at is the 4 and the 2. What factors do they actually share? Well, they both have a 2, don't they? They don't both have a 4, because I can't pull a factor out of 2, right? There's no 4 over here as a factor of 2, so I can pull out a 2. What else do they share in common? It looks like they both have an m and only one. This one has an n, but this one does not. And this one has a p, but my first term does not. So let's put back in parentheses what they don't share in common. So what would I put here that when I multiply it with 2m would bring me back to 4mn? It looks like what's left is the n. So when I distribute that, let's look at that. Oops. When I redistribute this, I'm going to have, oh, wait a minute. Silly me. There's one. Hopefully you're sitting there thinking, wait, Mrs. Quigley, you're missing something. I would need to put a 2 back in there and an n. So when I multiply this, I end up with 4mn, which is where I started. Okay, now let's look at the next term. We have a minus sign here, so we're going to put that inside our parentheses. What is missing over here that when I multiply it, if I were to distribute this, would bring me back to 2mp? It looks like it's just a p. So 2m times p would give me 2mp. Okay, so if you look at this and distribute the whole thing, look what happens. 2m times 2n is 4mn, and 2m times p, we have the minus sign here, is 2mp. And look, that brings us back to this, doesn't it? Okay, so really we want to start getting in the practice that we can identify the greatest common factor without having to do it the long way. It's okay if we do. In fact, let's just look at that. So if I did it the long way, I would take 4mn and I would prime factor it. And I would take 2mp and write that in factors. And then I can identify what they have in common. They both have a 2 and they both have an m. And look, that's what we factored out to start with, isn't it? And then everything else went back into, let me put those in green, everything else went back into the parentheses. So we pulled out the 2m, and back inside we put the 2n minus p. Okay, let's look at 3, because 3 is a really long one. And if I had to write all that out, I certainly could do it. But let's see if we can maybe train our eyes to pull out the greatest common factor. So the first thing we want to look at is, let's look at our x terms here. We have x to the 4th, x to the 2nd, and x to the 3. What do they all share? They all have at least 2 x's, don't they? So let's pull out x squared. Let's look at our y's. We have a y squared, we have a y to the 5th, and we have a y to the 6th. What do they all commonly share? They all have at least 2 y's, don't they? And then finally, let's look at the z's. We have z to the 3rd, z to the 9th, and z to the 7th. They all have at least the z to the 3rd. 3 z's, right? So there we have pulled out our greatest common factor of those 3 numbers. Now, what we had to put back in parentheses is what remains. So we look up here, we have x squared pulled out, but here we actually had x to the 4th. So we need to put back in there x squared, because x squared times x squared gives me this x to the 4th. Remember, this is like the opposite. When we factor, it's the opposite of distributing. So distributing is what would bring us back to the original form. Okay, what about y's? Looks like our y's match up and our z's match up. So we're good to go there. Now, I just want to see if I can get rid, I knew that was going to happen. There we go. Okay. Now, let's look at the second term. And note, we have a plus sign here. So we're going to put the plus sign back in there. Let's pay attention to the second term over here. Okay, what did I pull out? I have an x squared pulled out, and I have an x squared here. So we're good to go on that. I have a y squared here and a y to the 5th here. So I need to put some of those y's back inside here. How many? 3 of them. How about the z's? I have 3 z's here, and I have 9 up here, so I need to put 6 of those back in there. Okay, so that takes care of that. And we're going to redistribute this in a minute to make sure we've done this correctly. All right, now we have a minus sign here, so that's going to be what goes back inside here. Let's take a look now. So we have x squared, but I have 3 x's here, so I need to put 1 back in. I have y squared over here, but it just so happens I have 6 of them up here, so I'm going to need to put back in there 4 of those. I have z to the 3rd here and z to the 7th here, so I'm going to need to put some z's back inside, 4 of them. Now let's redistribute this and see if it actually works out. Let me get rid of these little lines if I can. Perfect. Alrighty, let's redistribute. So if I take this whole big term and I multiply it with this x squared, I would have x to the 4th, y to the 2nd, z to the 3rd. Is that what I have up here? X to the 4th, y to the 2nd, z to the 3rd. Yes, it is. Perfect. All right, let's get rid of some of this jazz that's going on around here. And see if I can maybe get rid of some. I get frustrated a little bit here. Okay. Now, let's take this arrow and let's distribute it over here to these guys. Okay, so all of this is now going to be distributed with that second term. We have plus x squared times, we have x squared, then we have y squared times y to the 3rd, which is y to the 5th, and z to the 3rd times z to the 6th is z to the 9th. Is that our term above? Yes, it is. X squared, y to the 5th, z to the 9th. X squared, y to the 5th, z to the 9th. Okay, hopefully you're with me so far. Minus. Okay, now I'm going to distribute all of that with all of this. So I have x squared times x to the 1st. That's x to the 3rd. My y squared times y to the 4th is y to the 6th. My z to the 3rd times z to the 4th is z to the 7th. Is this term the same as this term? X to the 3rd, y to the 6th, z to the 7th? Yes, it is. So when that proves now, and I'm going to get rid of this so there's not so much stuff here, but that proves actually that I distributed back to the original form based on what I pulled out as the greatest common factor and what I used to make the rest of the factors. So I have 2 factors here. I have x squared, y squared, z to the 3rd times all of this big stuff in here. Okay, so that's the answer to that. Okay, now how do I use, well, actually, let's see here what's down in the practice. Okay, second part of this is how do we use this now to simplify another type of a problem? We factored out the greatest common factor in the first 3 up there. Now the next 2, what we want to do is we want to actually simplify this 2x minus 4 over 2. So we're going to actually factor out the greatest common factor. So what is the greatest common factor of 2x and 4? Well, it looks like they both have a 2, don't they? Let's put back inside our parentheses what it would take to come back to 2x minus 4. So 2 times x is what would give me this 2x. Remember the minus sign stays in there? And multiplying a 2 here would bring me back to this 4. And this is over 2. Now, if you don't believe me about that, let's just look at this. 2 times x minus 2. There's 2x minus 4. And isn't that what we started with right up here? Yes, it is. So we factored out the greatest common factor is 2. And then we put back in parentheses what it would take to come back to the 2x minus 4. And it's all over 2. Now keep in mind, I have two factors here, 2 times x minus 2 right here. And I have a 2 on the bottom. Because those are factors in the numerator, I can cancel those two out. And now I am simplified down to x minus 2. So all of this was simplified to that. Okay, next, let's look at the next one over here. Okay, so this one has a few more terms in it. Let's see if we can pull out the greatest common factor of 3x and 6x squared. Looks like they both share, I look at my numbers first, a 3 and a 6. Looks like I can factor out a 3 for both of those. And what else? It looks like they both have at least one x. So let's pull out an x. What goes back inside the parentheses would be what it would take that when I multiply it would bring me back to this term, 3x plus 6x squared. Well, 3x is already all factored out. So what would it take? What would I multiply? I have to have a term in there. I would put 1 because 3x times 1 brings me back to this 3x. Okay, we put our plus sign in here. And what would it take? What would I multiply with here to come back to 6x squared? Hopefully you said 2x, because 3x times 2x is 6x squared. And what's on the bottom is 3x. So notice I can cancel my 3's and my x's, and I'm left with 1 plus 2x. I can drop the parentheses off. And all of this up here simplifies into that 1 plus 2x by factoring out the greatest common factor and then canceling. Now there is one common mistake that kids make a lot. A lot of students will do this, so I want to make sure you know this is not acceptable. If you had 3x plus 2 over 3x, you cannot cancel out those 3 x's. The reason is, notice that this is a plus sign. Okay, these are not factors up in the numerator. Only if they're factors can you cancel. So if you had this, then it would be okay to cancel. But this is a big fat no. So make sure you're cautious of that. If you're adding or subtracting, you cannot cancel. You cannot disturb what is part of the addition up there. But when there are factors, because why? Because 3x over 3x in this case is a 1, right? That becomes a 1. Okay, but it's not so when you have an addition or a subtraction over here. So keep that in mind. All right, and you might want to write that in your notes if you like. You can actually put here 3x plus 2 over 3x. Show that you canceled it, but say, oop, nope, can't do that. In fact, I'm going to change it to red and say, no, we cannot do that. No. But you can if it's 3x times 2 over 3x, then that's okay. Okay, that's something you might want to put in your notes as a memory recall. Okay, so let's look at our practice set. I'm actually in an office where I don't have my book right in front of me, so I don't know what page this is on, but if you find lesson 35 where it begins, this is probably coming from the practice set in there. Letter A, we are going to factor out the greatest common factor of this. 15a squared z to the 8th power minus 35 z to the 5th a. All right, so let's look at these. You can do this the long way if you want to. I think we should go ahead and start thinking about doing it just to begin to train ourselves what we're looking for here. So what's the greatest common factor of 15 and 35? What will go into those? The greatest common factor that you can actually take to divide into each one of those, it would be 5. Okay, so they both share a 5. What else do they share? It looks like they both have at least one A. So we're going to pull out one A. And it looks like they both have at least 5 Z's. So we're going to pull out those 5 Z's. That's what they share in common. There's our greatest common factor. Now we're going to put back in parentheses what it would take to come back to that form. So I have a 5az to the 5th as our greatest common factor. What would it take to multiply to come back to this? 15a squared z to the 8th. Well, we would need a 3 to times the 5 to give me 15. I have one a out here in the greatest common factor, but I have a squared right here. So I would need another a, and I would need 3 more z's. Minus 7 times 5 is 35. We don't need the a, right? Because the a is already pulled out. There was only one a. If I put another a in there, that's going to become a squared. And that's not what we have up here. We have only one a. So we do not need to put an a in there. But it does look like, oh, we don't even need the z's, do we? Because we had at least 5 z's. So we don't need that. So what I'm going to do is actually move this. And there is our answer. Now I can redistribute this, and it's a good idea to do that just to check yourself to make sure you've done it correctly. So I would have 15a squared z to the 8th minus 35a z, now I'm doing this, to the 5th. And is that back to our original problem? Yes, it is. It's in a little bit different order there, but it still comes right. We have a z to the 5th down here, and it's a z to the 5th is backwards up there, but that's okay. It's the same thing. We know we can multiply in any order. Okay, so you can test it by redistributing it and making sure that you've done it correctly. Here's the answer. Let's look at B. B is a little bit longer. We have 2a squared b squared plus 2a to the 3rd b squared plus 2a to the 3rd b to the 6th. All right, so what do they have in common? Looks like they all have a 2. So let's pull that out. It looks like they all have a's. What do they have at least? It's always going to be the one that's the lowest number because they all have at least 2 a's. You can't put a to the 3rd because our first term over here is 2a to the 2nd. And as far as our b's, they all have at least 2 b's. So let's put back in parentheses what we need to come back to the original problem. All right, so what would I multiply 2a squared b squared with to come back to 2a squared b squared? Oh, goodness, how about just a 1? Plus, right, I get my plus sign here. Okay, what would I multiply with to come back to 2a to the 3rd b to the 2nd? I have a 2. Oh, looks like I have a b squared, so that's okay, but it looks like I need an a. So if I multiply this, I'm going to have 2a to the 3rd b squared. That's what I have up here, 2a to the 3rd b squared. All right, what about the third one? I have a plus sign. And I would need to multiply an a and a b to the 4th. So check that out. 2a to the 3rd, b to the 6th. Look here, 2a to the 3rd, b to the 6th. So factor out your common factor, greatest common factor, and then put in parentheses what it would take to come back to your original term. This is your answer. Let's look at C. Letter C, we're going to use our greatest common factor in order to simplify, so we might have to cancel here, which would be nice, so we can make it a smaller, more simplified expression. All right, so I have 4 minus 4x over 4. Let's factor out the greatest common factor. Well, right off the bat, I can see the numerator, they both have a 4 that I can factor out. What would go back inside my parentheses here? What would it take to multiply with 4 to come back to this original 4? How about a 1? Minus, and what would it take over here to be multiplied to come back to 4x? Should be an x, right? Okay, so now on the top I have two factors, 4 times the quantity 1 minus x over 4. Okay, so it's safe to cancel these because the numerator is set up as factors, and we can cancel. That is legal. So our answer is 1 minus x. So we went from this 4 minus 4x over 4 down to the simplified form of 1 minus x by simply factoring out the greatest common factor and then canceling. Letter D, 7x minus 49x squared all over 7x. Okay, so what can I factor out? I'm going to come down here and do it. What do they share in common? Let's look at the numerator. The 7 and the 49. What's the greatest common factor there? Hopefully you said 7. What else do they share in common? It looks like they each have an x, doesn't it? What goes back in the parentheses? What would it take inside here when multiplied with 7x would bring me back to this 7x up here? Hopefully you said 1. And we subtract. And what would it take to multiply with this 7x? What would it take inside here to come back to 49x squared? Hopefully you're thinking 7x, right? 49x squared. Okay? There we go. All right, all that over 7x. Do you see how nicely this is working out? We can cancel. So our answer is 1 minus 7x. Okay, and that is today's lesson. So please make sure your notes are filled out. If you have any questions or you need a Zoom call, please let me know. I'll be happy to try to meet up with you on Friday afternoon. Alrighty, and I'm going to go ahead and work on the next lesson and get that uploaded for you. So hopefully I won't say I'll see you then because it'll all be on a recording.